Okay, thank you very much, Rami, and welcome and greetings to everyone here with us today. We have almost 700 attendees. So again, Assalamu alaikum wa rahmatullahi wa barakatuh. Let's just, get into the action as quick as possible. So today we're going to talk about deserialization attacks. Probably many of us, let's say, heard or read this title of this type of vulnerability, deserialization attacks. What are they? It's a bit more, let's say, vague kind of a vulnerability, where sometimes you need to go deep into how programming languages work and how objects are created in order to understand how these vulnerabilities work, and they differ greatly between languages, between programming languages used in web applications. So without, as you said, Ram, without further ado, let's just get into business. Before that, that's me. I am Mohammed Aldoub. I'm a security consultant from Kuwait. I have worked in creating Kuwait's national infrastructure for PKI, cryptography, smart cards authentication. Then I, let's say, veered into training, where I delivered training workshops in many parts around the world, in many conferences. Now I'm focusing on API security, cloud security, web application security, and hence we're going to talk about deserialization attacks, and we're going to see some live examples, some debugging, some reverse engineering. I hope I have enough time for all of that because it's going to be really interesting. So what is a deserialization attack? What is deserialization? Deserialization is the reverse of serialization. So we have serialization and then we have the reverse of that, deserialization. So what is serialization in the first place? Serialization, simply put, is the process of converting an object. For example, we have programming languages, we create objects, and suppose you want to send this object from this server to another server, from this computer to another computer. So we take this object from memory and we try to convert it into a format that is possible to send over the network, to store in a database, to save in a file. So this process, taking the object from memory and then storing it in a file or a database or send it through the network, is called serialization. So deserialization is the inverse of that. We have this simple graph here. On the left we have serialization, we have the object, and then we kind of stream it into bytes or characters or string, and then we store that into a database or a file, or for example send it through the network. And then when the recipient wants to get the original object back that was saved, they do the reverse of serialization, which is deserialization. So let's see an example here really quick. We're going to see some code examples really quick, but let's just say now that we understand what is serialization, as we said, converting an object into a string or byte format, and then deserialization is the reverse of that, taking that string or that file and then read the serialized object in it back into the original object again. So deserialization attacks come here in the middle. The attacker would try to modify that serialized object so that it deserializes into something else. When we serialized the object, it was an original object. Then we did the serialization process. It became that text or byte string that we sent over the network or saved in a file. When the recipient wants to deserialize the object, they expect to get the original object back. The attack here is if we change this serialized object into something malicious or into something that will deserialize into an unexpected object, different from the type of object or the details that the recipient was expecting when they did the deserialization. So how attackers can attack serialized objects, for example, is to add their own custom logic into that object. So you send an object that contains methods or fields, properties, a string, a date, or integer, for example, and some functions here and there. Suppose you can inject your own custom functions so that when they get called, when the object gets deserialized, then your code, the malicious code, gets executed instead of the original code for that object. Or suppose that the recipient is expecting an object of a different, let's say a particular class, for example, a string class, and then you send an object that contains, that belongs to a different class. So they would try to deserialize into a different class from the one that they expected. Or, for example, trying to attack, control the fields into that object so that they can result in a different outcome or different logic than that was originally expected. One of the most popular deserialization attacks lately was the SharePoint attack, CVE 2019-0604. It was a .NET XML deserialization vulnerability in SharePoint via post requests. So it means that SharePoint was vulnerable at one of the endpoints, but you can send a post request that will result in taking the user input that was, for example, provided by an attacker, and then you would try to, the SharePoint server would expect that this is an XML serialized object in a certain type, and then the attacker would try to send a different serialized object that upon deserialization would actually run a different type of object, which will run our own custom .NET code, which means RCE, remote code execution. So let's just go really quick here. The reason XML serialization is used in .NET Framework is that it is really easy to code. It is really easy to understand. It's in XML format, and it is in plain text, so it's not a binary format, it's a text format. So easy for people to actually debug and read. That's why developers use XML serialization and deserialization in .NET Framework. Unfortunately, insecure usage of XML serialization results in critical remote code execution vulnerabilities, which was the case here for SharePoint. Let's see a really simple class of XML serialization. We have this class. It's called class to be serialized. It has properties name and ID. So let's try to write the code to XML serialize it. We have the first line here, to be serialized, ABC equals new to be serialized. Then we're going to set the ID to be 123 and the name to be Mohammed. And then we will call the XML serializer of .NET. If you see how it's called, we call the new XML serializer, and then we have to give it the type of the class we're going to serialize. So it expects to know which type of object we're actually trying to serialize. And then we can just use a string writer, and then we will call serialize to actually convert this class into an XML serialized format. If you run this code, this will be the result. See this here below, we have an XML element, a tag called to be serialized, the same as the name of the class, and then we have the field name and ID with their values that we actually set for this class. So let's try now to do the reverse. Let's try to take this string and then let's try to deserialize it back into the original object. We can just take the string again, and then we create an XML serializer class with the same type, of course, and then we try to call deserialize on it, giving it this string that we have actually created before. So now we will take the XML string and then we'll try to deserialize it. If we debug this piece of code, we can see that we have created a new deserialized object that contains the same values that we have seen before. So this is a simple XML serialization deserialization. Now, as an attacker, there are some limitations for this exploit, especially XML serialization.NET. It has some conditions that can be tricky. For example, we can't just play with the serialized object and create our own serialized object as we please. We have to follow some certain rules in .NET language for the XML serialization. The first rule is we can only serialize public members. If we have any private members or any function, they will not be serialized. Only public members will be serialized. It cannot serialize interfaces, and it cannot serialize classes it doesn't know. So we can only serialize public fields. We cannot serialize interfaces, and we can only serialize classes we know. So if we throw a class that the XML serializer doesn't know or doesn't expect, there will be an error. If we try to serialize something with a private field, the private field will not be included in the serialized string. And if we try to serialize a class that contains an interface, the serialization will also fail. So here we have a simple code example. Class called easy. It has a public string, public integer, and a private integer, a private string. a function that sets these values. Let's try to call this piece of code, something really simple, just call it. And then we see the XML serialization results. Now let's see the XML here, easy, and it contains the public string and the public integer. Even though we set the private values to be 999 and XYZ private, the result of the XML serialization did not contain the private members. So this means that when we have private members, they don't get included in the serialized string. So we can't really depend on any private members for exploitation in a deserialization attack. Let's see what other limitations exist with XML serialization. Let's try to create a class that contains an interface. Here we have an interface to a dictionary. So let's try to XML serialize this class with this code. XML serialize of this class, and then we try to create a new class, and then we try to serialize it. Now, since it has an interface, and as we said, one of the conditions for XML serialization is that the class should not have an interface. If we did have an interface, we'll have an exception in the serializer. It says cannot serialize member interface dictionary because it contains an interface. So as we said, we've seen that we can only serialize public members. We can only serialize classes that don't contain interface. And the third condition for the XML serializer is that it should only serialize or deserialize classes it knows at runtime. In this piece of code, we try to create a new XML serializer with the type of object. So it's a dynamic type. It doesn't really know what kind of thing we're going to throw at it. If we try to serialize the easy tab, let's see here, we get the error. It says easy was not expected. The XML serializer expected an object type, and then we sent to it a class called easy that we created. So the XML serializer did not expect this class. It expected an object only, object type. We sent a class of a different type, so it gave us an error. So we have the limitations here. Let's see how we can bypass these limitations as an attacker. Let's say the first limitation, only public members can be serialized. No methods and no private members can be used. What can we do against that as attackers? We should try to find classes whose private members are not needed for exploitations and whose public, let's say, fields are enough to invoke the useful functionality for the attacker. The other problem is that it cannot serialize interfaces. So let's start to find an object to deserialize that doesn't contain an interface, and we'll see some examples of that. It also cannot serialize or deserialize classes it doesn't know at runtime. For this case, we'll try to look for vulnerabilities where the attacker can supply or can influence or can request or can force the type of object being sent to the deserializer. And we're going to see example with our SharePoint vulnerability. Now, as we said, we have three conditions that we have to satisfy. So we have to look for a class that satisfies these three conditions. Such a class is called a gadget. So a gadget is a piece of code that we can invoke. It's a piece of .NET code that exists in the application previously. For example, it could be in the .NET framework itself, the original .NET framework, or it could be one of the classes included by default in this application you're trying to attack. So we'll just try to deserialize into an object of that type because it's already known to the target or the vulnerable application. The most popular gadgets actually get included in the .NET framework itself by default. So they are built-in types, which means that any .NET application is going to have those interesting classes which we're calling gadgets. So it's a piece of code that any .NET application will have, which we can utilize, because remember, we can't just supply any class that we want. It has to be a class that the application knows beforehand. Otherwise, it will say class not found. So a gadget is a type of class that we can, that is already loaded in the application and that contains useful functionality for us as attackers. So examples of useful functionality is, for example, running code, running applications, reading or writing files and things like that. So as we said, conditions for a gadget, it needs to be found in any .NET application or at least the target .NET application. It can be serialized with no issues, should satisfy all conditions, and its functionality can be utilized to perform useful actions for an attacker. and it can be invoked automatically because, as we said when we did XML serialization, we can't call functions. We can only set our own public methods. That's not really easy to find, so lots of research by researchers has been done. Lots of, let's say, conference talks has been done in Black Hat and other conferences where they show or display gadgets that they found, which anybody can actually include in their deserialization payloads. One of the most popular classes in .NET for code execution is called system diagnostic.process. It allows remote code execution by calling the method start. You give it an application name, for example, a PowerShell command line argument, and for example, calculator or Bing or any other application you want, and it will start that application. So attackers utilize this class to run their own custom PowerShell commands, for example, that will do connect and do malicious actions on the target server. It has a public property called start info, and it has a public other public properties called arguments and file name. So this is a really good gadget because it contains arguments, public arguments. Remember we said we can't use private members, only public members, and they contain public members called file name and arguments, which means that if we put our application name and arguments, the options for the application, into these public members, they will be serialized correctly in the XML serializer. So if we try to run this, let's say serialize this class into XML serializer, it will fail because this class contains an interface. Remember, we have three conditions. Only public methods get serialized in XML, and the class must not have an interface. Unfortunately, process does have an interface, so it will not be able to be processed in the XML serializer. So we have to look for something else. One of the most popular research has done on the field of .NET serialization attacks is by Alvaro Munoz and Alexander. Let me see the name. Alexander Mirosh. It was done in Black Hat. The presentation is called Friday the 13th JSON Attacks. They displayed some samples of gadgets that can be really useful to run XML serialization attacks because they actually contain public methods that are useful for exploitation. They don't contain an interface, and they allow you to kind of specify your gadgets in runtime. So one of these popular gadgets is called ObjectDataProvider. This class is really interesting because it contains a method called a field called method name and method parameters. So what this class does is it wraps or contains inside it another class. So you say create an object data provider of whatever class that you want, and then you will give this class the method that you want to call and the parameters. So this is sort of like an object caller, let's say, class. You can give it any other class. It will call it for you. It will run its method for you. So this is really useful for us because in XML serialization we can't directly call any method. We can only set public fields. So the object data provider is a really useful gadget that we can use to wrap inside it or put inside this class the malicious object that we want to create. So if we check the code of this class, it contains a method name, a string, a field, a public field called method name. This public field has a default setter which calls a function called refresh. If we check the code for function refresh, it calls a function called begin query. If we check the code for begin query, it goes all the way until it calls a function called query worker. So this is all inside this object data provider class. And then if we check the code for this function, we can see that it calls something called invoke method on instance. So what it means is that when we set a method name on the object data provider class, it will go to the wrapped class or boxed class inside and try to extract methods from it and try to call them. So that's really interesting because it allows us to actually wrap classes that would otherwise be unserializable by XML. Now, if we check the code for invoke method on instance, we can see that it calls invoke member on the method name that we have previously sent. So what it means is that we can set a method inside the object data provider which will be set in the code, and then the object data provider will call it automatically for us without us having to do that, let's say, specifically. So let's see the code here in the middle. Static void main, we create an object data provider, X, new object data provider, and then we add a method name, which is start, and then we create an object of the internal class itself. Here we have system.diagnostics.process, which is the most popular RCE class used in .NET framework. And then we add parameters for this function. We'll say run CMD, run the Windows CMD class command, sorry, and then give it the option /C, which means run the next command, which is calc. So if we run this code, it will serialize an object that contains a way for .NET method to call the CMD utility in Windows and run the calculator application, which is what we call, popping a calculator in the world of expert development. Now, if we try this example, that we have seen, and we try to serialize this object data provider, which inside it contains the process, system diagnostic process, it will say that it cannot do the serialization because it did not expect the process class. As we said, XML Serializer has a condition that you must define the type of object it will deserialize. In this case, we only give it the object data provider class. We didn't give it the internal class itself. So that's why it cannot know, it doesn't expect this process class inside it, so it will not be able to serialize. So how can we bypass this? Also, the same research done by Alvaro Munoz and Alexander Mirosh, the one we talked about before, shows that they have went on and researched the .NET framework. They have found more interesting gadget. They have found a gadget called expanded wrapper. Let's see what expanded wrapper is all about. Expanded wrapper, if we try to decompile its code, it's a class in .NET that actually expands two types. So as we said here, as we see here in the example, object data provider can only contain one class inside it. And when try to do that in XML Serializer, XML Serialization said, I know object data provider, but I don't know process. So the serialization failed. In the expanded wrapper class, this can solve our problem such that it actually can expand two classes at the same time. So we can add the object data provider and the process itself. So the code here that we have seen is the same. We create the object data provider to wrap our process class inside it. And then we wrap all of these together, these two classes inside the expanded wrapper, and then we serialize this one in XML directly. So we have the original system.diagnostic.process class. We put this one in a bigger box, which is the object data provider, and then we put this one in a different, also bigger box, which is the expanded wrapper. So the XML Serializer will open the expanded wrapper, and then from inside it will open the object data provider, and then from inside it will open the system.diagnostics.process class in order to run our malicious payload. All of this chained serialization is done in order for us to satisfy all of the XML Serializer's conditions. So we will satisfy condition 1, that only public methods can be used, satisfy condition 2, that we cannot serialize something with an interface, and satisfy condition 3, which is the XML Serializer must know the type of classes to serialize at runtime. If we see the code here at the end, XML Serializer Y equals XML Serializer of type of expanded wrapper of type process and object data provider. So the XML Serializer now knows all of the serialized class types beforehand, which will satisfy its condition. If we run this, however, we will see something really interesting. The XML Serializer now understands and sees all of these objects, classes, sorry, but then it says, I cannot serialize a process because it contains an interface. So we violated the second condition, is that the XML Serializer must actually only serialize objects that do not have an interface, and system.diagnostics.process contains an interface. So this will fail for us. How can we bypass that? One way we can do that is by checking the source, the documentation for object data provider from inside Microsoft Developer Network, and we can see that ObjectDataProvider enables you to create your object in XAML. XAML is like a different, similar to XML. It just has different ways of defining properties and fields, but it's almost identical to XML. So what it means here is that ObjectDataProvider, instead of doing this, we give it the class directly. Instead, we can give it a XAML string that contains inside it the classes that we want to serialize. So let's see an example. Upon doing some research online and reading the documentation, reading some examples of using the ObjectDataProvider, we can discover that the ObjectDataProvider can actually be, let's say, serialized or written in a XAML format, a XAML string, which is similar to XML, and then all of this can be plugged into our original ObjectDataProvider. This is a way for us to hide from the XML serializer the system.diagnostics.process object, which contains an interface. Essentially, what we're doing here is that we don't want the XML serializer to see that we actually have an interface. So we're going to hide it in a XAML string and then let it deserialize it at runtime without knowing that it contains an interface. All of this, let's say, big loop and chaining all of these, chaining all of these gadgets together can be done using a command line tool called why-so-serial.net. You can find it in the references and you can find it in GitHub. Why-so-serial.net does all of this for you instead of having to write all of this code and then creating your own payloads for XML serialization. You can just use this tool why-so-serial.net and you can just tell it, I want a payload for XML serialization, and this is the command line that I want to run, calculator, ping, PowerShell, anything like that, and it will do all of this for you. It will run the serialization process, it will run, do the XAML string and then serialize it in XML and then give you the result which you can plug into your, for example, burb suite and then send to the vulnerable endpoint. So let's see what kind of object we end up with. Essentially what we're doing is that we're creating an ObjectDataProvider, now not with a system diagnostics process class, which will fail to serialize, but with a XAML reader class. Essentially we're hiding the XML serialization, the details of the class inside this XAML string such that the XML deserializer does not complain about the interface that's included there. So if we run this piece of code, we'll create our own ObjectDataProvider, and then we will wrap this one inside the expanded wrapper like we did before. Now expanded wrapper is for the type of a XAML reader and ObjectDataProvider instead of process. If we serialize this, it will serialize correctly, it will not complain, and it will show us the following string in XML. If we see to the right, to the left, sorry, that's the XML string, expanded wrapper of XAML reader and ObjectDataProvider, and inside it, it contains the process. If we see here in the middle, can you all see my mouse pointer? I hope you can all see the mouse pointer. We are actually hiding the process, the system diagnostics process class inside it, which contains, if we see here, the CMD and the calc process to run. So this is the piece of code that does all of this for you, creates a serialized XML payload. If we see all of these details, you can really appreciate how why-so-serial.net tool can do all of that for you, let's say, directly without having to play with all of these internals of .NET and all of these pieces of code where we try to bypass the limitations of the XML serializer. So the end result is that we have an XML serialization payload that runs the calculator application when it gets deserialized. Let's say an example. Our most important example here in the, let's say, lately in the world of .NET vulnerabilities was the SharePoint vulnerability. Let's see how it works. The SharePoint vulnerability, if you see the analysis done by the ZDI, the Zero Day Initiative project, they did a much more detailed XML, SharePoint analysis of the attack. What it does is that it's an XML serialization attack. And this library, Microsoft.SharePoint Business Data Infrastructure Entity Instance Encoder class. If we take this class and we throw it into the debugger, the decompiler, we can see that it contains the following function, which is called decode instance entity instance ID. If you check how it works, it takes a string, tries to see if it starts with double underscores, and then tries to decode or read that string. It's a long process. We're not going to, let's say, discuss it in detail. But what it does is that it takes the string, it does hex decoding on it because it's in hex format. It will do the hex decoding, and then depending on the value of the string that was hex decoded, it will try to actually determine what type of object we have. If you see the object types, one of them is actually object. For example, we have integer, string, date, time, and then we have object. Object is interesting because we can influence it or we can control it as an attacker. So I can send to SharePoint server, the variable SharePoint server. I can tell it the type of object that I want, the specific type of object that I want to actually run in the deserialization attack. So if we check the code here, if the object type is object, it will try to split the string on the colon symbol, and then it will try to extract the type name of this of the string. So what it means is that the attacker will tell the deserializer, this is the type of object that I have. Remember when we said we had we have 3 conditions for the XML serializer? The third one was the XML serializer must know the object type beforehand. It must know it in runtime. And this vulnerability here in SharePoint, the developers did a really big mistake, which is taking the object type from the string provided by the attacker. So the attacker now can control the dynamic type, can supply their own type, which will be sent to the XML serializers. So the attacker can say, I will send system.diagnostic.process class, I will send an expanded wrapper, I will send a date time, I will send the object, I will send whatever object type I want, which means that the SharePoint server will blindly accept whatever type of object, no matter how malicious the attacker is sending to the deserializer. And then after that, if we check the code, we will see that we take the length and then we take the actual object itself that was serialized in XML, and then we will try to call deserialize. So what we're doing here is that we're creating an XML serializer from which type, the type that was sent by the attacker, and then we will try to deserialize the XML serialized string that was also sent by the attacker. So the attacker now controls the whole flow. The attacker controls the type of the object to be sent, and the attacker also controls the text of the object itself. So we have a full head-on XML serialization attack, and SharePoint server is accepting everything the attacker is sending. So now what remains is that we now want to write the payload. We want to write the actual object and the type of that object such that we send it to the XML serializer that is running inside SharePoint.
Mohammed?
Going forward, yes?
Sorry, Habibi. So we're just about to come to the end of your kind of timing there. Would it be possible to jump into the demonstration?
Yes, of course. Yes, of course. Okay. So to demonstrate the vulnerability, now before we jump to this demonstration, there is the very, let's say, detailed explanation of how SharePoint expects this attack. And this explanation is actually found on the Deserialize GitHub page, which I will share in Twitter, and I will share. I will also ask the guys to share it to the whole attendees list. We will all of this we will see let's say live using the Serialize attack tool. So what we're doing essentially is that we want to reach the state where we actually have a vulnerable SharePoint server, and then we will launch the XML payload attack against it, such that it will actually pop calc on the server. Now, let's go to the demonstration. We have a server here running Amazon. So that's the server. It expects our payload. And then if we visit the page, it's a SharePoint server. And that's the URL for the SharePoint server. Now, remember that I developed a tool called Deserialize to actually run or do this type of attack. So now I will call this tool. I will say Python and then deserialize.py. I will give it the URL of the server here, and then I will give it -c, which is the command. So I will say run the command calc. Now I will run, enter. Now let's see what it does. Here it says the deserialized payload is, so this is the XML payload it's trying to send. It's an expanded wrapper of type XML reader and type ObjectDataProvider, which inside it calls the system.diagnostics process. Let me see, where is it? Where is it? Where is it? Where is it? There it is, system, diagnostics, and then process. Here it is, process, and then we will send to it the CMD command with the option of running calc. So this is the actual XML that will be sent to the server. So now let's do it again, just to be sure. And then let's see our server back again. Let's look for calc, and then we have seen that calc is actually running. So the payload resulted in execution of the serialization attack. If we do it again, just to be sure, and then we have calc running. So just to wrap up what we're doing here, what we did simply is we created a way to shortcut and do all of these details in one full swoop. So instead of writing our own code and trying to debug it line by line, I created Deserialize to take this ready XML payload attack and then plug inside it the code that we want, the command that we want to run, and then we will create an XML object of this type, which will bypass all of the XML serialization conditions that the .NET framework expects. It will send it to SharePoint on the endpoint that we can see when we decode the SharePoint DLL. And the SharePoint DLL is actually included in the GitHub repo for Deserialize. So if we debug the DLL, we can find the path inside which we can launch the vulnerability, and that is the path. And if we see the example here in the command line, this is the path that we actually called, and we sent the payload to this path, which resulted in XML deserialization attack running the calculator application inside here, which of course could be anything much more malicious like PowerShell or anything like that, or for example a ransomware or any other type of malicious attacks. And this particular SharePoint vulnerability is still very popular. Attackers are still ransomwaring organizations and entities using this vulnerability because unfortunately not many people update or batch SharePoint, and they don't blame it because SharePoint management and maintenance is really difficult. So this let's see in a quick hurry, Rami, do we have the time to explain deserialization defenses, or maybe you can just skip that?
If you have 30 seconds to explain it.
Okay, so instead of trying to explain all of that, I'm going to post the slides here. So people can just read them at their own time. I'm going to post this sometime soon. And last but not least, the references and the shoulders of the giants that I stood upon. You can see examples of serialization attack references. Here you can visit all of these talks and tools and presentations to understand more about deserialization and especially the SharePoint deserialization attack. So I think I'm done now. And if there's any time for questions, I'd be more than willing to answer. If there's no time or not enough time to answer all of questions, also my Twitter account is open for everyone that wants to ask questions.
Mohammed, Aldoub, thank you very much for your presentation. That was fantastic. I hope we can see you on Slack as well. Maybe you can take some questions on there. But for now, we want to make sure that everyone gets their refill and their popcorn ready for the next presentation, in which we'll start in about 5 minutes time. Again, Mohammed, thank you very much.
Thank you. You're welcome. And thank you for all the attendees and everyone who had to keep up with my fast pace and all of these details inside the code. Thank you very much for your attention and your time.